Hello everyone. So now we'll be discussing about acceleration due to gravity. My name is Shashin Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. So first of all, before going into this, let's try to revise what is acceleration. What is acceleration? As we know, it is nothing but rate of change in velocity. Okay. What about its units? The SI unit of acceleration is meter per second square. Basic definition in terms of change in velocity. But when it comes to the relation between acceleration and force, which law gives us that? Newton's second law. So according to second law, we can say that net force is equal to mass into acceleration. Or I can say acceleration is equal to net force upon mass. Acceleration is equal to net force upon mass. Two different definitions, but both of them are the same. Okay, this is fine. But our topic for today is what? Acceleration due to gravity. What does that mean? That means it is acceleration due to gravitational force. Acceleration due to gravitational force. Let's go into that. The only change here will be in place of net force. If I take gravitational force, that means the acceleration is because of gravitational force. Acceleration due to gravity. Very simple definition. Okay. We'll go into the details. Don't worry. But in simple terms, acceleration due to gravity is acceleration because of gravitational force. So Fg, if it is gravitational force, then gravitational force upon mass. Simple, right? Yes. Let's continue. So before going into that, for us to understand the derivation, there is some approximation that we have to understand. What is that approximation? So let's first of all look at the radius of Earth. Earth, as we know, is huge. And would you know what is the radius of Earth? On an average, the radius is about 6,400 kilometer. Radius of Earth is about 6,400 kilometer. Then, if I want to convert it into SI units, that is meter, 1 kilometer is 1000 meters. So you multiply with 1000, it becomes what? You add extra 3 zeros, meter. Now if I want to convert this in terms of decimals, let's see. From here to here, how many units or how many digits do we have? 1, 2, 3, 4, 5, 6. So what I can do is, I can just say that this is equal to 6.4 into 10 power 6 meters. That's it. It's on, we have 6 digits. So we are moving the decimal by how many digits? 6 digits. That is the reason why into 10 power 6. You multiply that, you will again get the same. So we got the radius. Is that clear? This is what is radius of Earth. So it is 6,400 kilometers. It is huge. But when we compare that to one of the highest buildings built by humans. For example, we know that Burj Khalifa, right? Burj Khalifa is the tallest building that humans have built until today. Until today, so if I compare with that, and you know what is the height of Burj Khalifa? It's around 828 meters. That's it. Where is 828? Where is 64 lakh meters? 64 lakh meters is the radius of Earth, whereas the height is 828 meters only. Right? So the Burj Khalifa is very, very, very small in front of radius of the Earth. 828 meters, 64 lakh meters. Huge. Right? So Burj Khalifa is very small when compared to radius of Earth. In fact, you can take other buildings also. Some of the tallest buildings are shown here, but all of them are shorter than Burj Khalifa. I know why are we considering that? Because this is the tallest building that we have built. Now in everyday life, generally everyday life, we go to what heights? 3rd floor, 5th floor, 10th floor, basic on an average, yes or no? So the height that we go will not even be 800 meters, no. We might go to, let's say, 100 meters maximum. 100 meters is huge. One room on an average will be around 4 meters high, 4 or 5 meters, that's it. So if one room, if I take it as of height 5 meters, then 100 meters will mean how many floors are there? 5 into 20 is equal to 100. So if there are 20 floors, then it would mean the height will be 100 meters. Right? So generally the heights that we consider, okay, so the height of objects on ground, or let's say near the ground, okay, it's better to say near the ground is very small when compared to what? When compared to the radius of Earth. Everyone agrees this? See here, radius of Earth is how much? 64 lakh meters. The height here for 20 floors is only 100 meters. Very, very, very small. Okay. So, let's say, simple maths. If I have to add H and RE, let's say I'll take height as equal to 100 meters. Just for an example's sake. It will be how much? It will be 100 plus 64 lakh meters. Which will be how much? 64 lakh 100 meters. But for approximation, can I say that it is almost equal to 64 lakh itself? In front of 64 lakh, 100 is very small, very, very small, tiny, neglected. Right, so this is, I can say that, almost equal to radius of Earth. H plus RE, height, general heights, okay. When you say height, do not get confused. Think of any height that you can think of in everyday life. Okay, that when compared to radius of Earth is very small. So any height plus radius of Earth is almost equal to radius of Earth. We can neglect the height. Now why is this important? You will understand, we will go into that. But the same point is mentioned here. In place of 100 meters, we have taken 500 meters, which is much more greater height. But ultimately, the point that we get is this. The same. H plus R is almost equal to R. Okay. Why is this important? You will understand that. Okay. Just hold on to this point. What point? Height plus radius of Earth is almost equal to radius of Earth. Just hold on to that. Okay.